which of the following is the graph of the region 1 is less than x plus y and x plus y is less than 2? So keep in mind that x plus y are the coordinates. So it's asking us or telling us, so you have a point, an xy pair, and you add those two coordinate values together. To answer this inequality, they must be, or this pair of inequalities, they must be greater than 1 and less than 2. So the sum of the coordinate pair must be between 1 and 2. There's quite a few ways to look at this, and if you understand the logic behind it, it actually falls into place pretty easily, even though when you look at this initially, it might not seem so. Okay, now let's analyze the answer choices and see what we can see. First of all, every one of the answer choices has a dashed line, shaded area, and then another dashed line. So those dashed lines, like I've told you already, are boundaries, and they have to do with the fact that these are inequalities. So if they were solid lines, the points on the line would answer the question. But because it's an inequality, the area between the two dashed lines are the coordinates that answer. So any point, if it's going to answer this inequality setup here, x plus y greater than 1, x plus y less than 2, the correct answer choice will be the shaded area, where every point inside the shaded area would be a coordinate combination, a coordinate pair, where x plus y would be greater than 1 and less than 2. Also, you see these numbers like 1, -1, -2, 2 on each of the answer choices. Those are the x and y coordinate intercepts. So this dashed line, this boundary, intercepts on the x at location of -2, 0. So that's left 2, up 0. And they just put -2 there. This point is where this top dash boundary would intercept the y, and that's over 0, up 2, and they just gave you the y value 2. This number tells us where this second dashed line, this line, intercepts the x, and it intercepts at over 1 in the positive direction, up 0, and they just gave you the x value of 1. And then, of course, this point right here is where it intercepts y-axis, and that is at 0, -1, and they just give you the y value. Analyzing these answer choices, you can also see that F, G, H all have a slope in this direction. That's called a positive slope, and J and K both slope in that direction, which is a negative slope. Just looking at slope would be one way to answer this problem. One other thing, F and K have a wider shaded area. They take in more points, where J, G, and H are narrower. They take in fewer points. The two lines are closer together. And you could answer this question just with that information. So now let's start looking at this logically. The XY coordinate pair must all add up to be greater than 1 and less than 2. So if you were to draw X and Y coordinates this way and set this up, if X were 0, what does Y have to be in order for the combination of these two to be greater than 1? Well, it would have to be everything 1.000001 and greater to be greater than 1, but up to 2. So if you had a number line, and there is 1, and here is 2, Y could be anything up to 2 and down to 1. So it's going to be between 1 and 2. So you can see that if X is 0, Y must be between 1 and 2. And if X were 1, Y would have to be between 0 and 1. One other thing I wanted to point out, this inequality of 1 x plus y less than 2 is actually two inequalities put together. So it's x plus y must be less than 1, and x plus y must be greater than 2. And one of the dotted lines is that value, and one of the dotted lines is this value. So if you're probably used to seeing y equals mx plus b as the definition of a line, you could turn these from inequalities into equations, and all that would do is make the dotted lines into solid lines, but it would answer a lot of the question just by knowing which of these dotted lines is truly graphed. Irrespective of the area between them, the lines must correspond to this and this. And that's another way to answer this question. So let's just look at this logically. With all that set up, these three, F, G, and H, are positive slope, and they all pass through the upper right quadrant, which is the positive, X and Y are positive. And these lines just keep on going, so the gray area would keep on going. So imagine that any one of these would have a pair that is miles out in this direction, where the X and the Y are both going to be positive. So you're going to have an X plus Y, and the X will be positive and the Y will be positive, and they will be very, very large, because this quadrant 1, is the positive quadrant, and these lines just keep on going. You don't know exactly what the points would be because we haven't figured that out, but you can assign any value to X, because at some point the X value will be in there. So you could say that it's 1,000. You don't know exactly what Y will be, but you do know it will be positive. So if you look at your two inequalities, X plus Y have to be less than 1, well, you can instantly know that F, G, and H won't work, because they have positive coordinates, and as those coordinates get bigger and bigger, they quickly will break through the inequality of X plus Y being less than 1. So the line can only pass through a very small portion of the positive quadrant of the graph. And so you know that it's got to be either J or K for that very reason. So we can eliminate FGH. So now let's look at J and K. And another way to approach this is to look at the width. This K answer takes in Y being 2 and Y being -1. So it takes in 3 units on the y-axis, -1 to 0, 0 to 1, 1 to 2. So it takes in 3 units. This shaded area is 3 units wide right there. But you know from the given that it can only be 1 unit wide, because you have between 1 and 2. X plus Y has to be between 1 and 2. So you can't have 3 units being between 1 and 2. Another way to look at this is just to pick the points on here. If Y is 2 on this and -1 on this, the -1 point just won't work. So if you had this point right here is 0, -1, add those two together, you get -1. Well, our first inequality says X plus Y, which is now -1, is -1 is not greater than 1, and the X plus Y has to be greater than 1. Another way to eliminate this one is just look at the origin point. 0 plus 0 is not greater than 1, so you could have eliminated this very quickly just by looking at points. And by process of elimination, it would leave you with J. And you could test these points and you would see that they work out. But let's also look at this by slope. You know that y equals mx plus b is the definition of the line, and the m is the slope. So let's go back to our given x plus y, and I'm going to say equal 1, realizing that that turns the dotted line into a solid line, but I know that this is an inequality, but for purposes of putting it into this slope formula, it'll just look better. And that is the same as, I just subtract x from both sides, y equals negative x plus 1. Now I've put it into this y equals mx plus b, where our slope is negative 1. And then let's do line number 2. That is x plus y equal 2. Do the same thing. Y equals negative x plus 2. Now we know both our y-intercept and we know our slope equals negative 1, which you would expect to see that the two slopes would be the same because they're parallel, or at least they appear, each one of these appear to be parallel. So we have a slope of negative 1 for one of our lines with a y-intercept of 2. We have a slope of negative 1 for the other line with a y-intercept of 1. So now we just find these two lines. Which of these graphs has a y-intercept of 1 for one of the lines and a y-intercept of 2 for the other line? So let's look over here on our graph. Our graphs, we're looking for a y-intercept of 1. Well, this one has a y-intercept of 1. This one does not. This one does not. This one has a y-intercept of 1 right there, and it also has a y-intercept of 2, so this one's still in the running. This one has a y-intercept of 2 here, but a y-intercept of negative 1 here, so we can eliminate this one. So now we have 2. The j has a y-intercept of 1 and a y-intercept of 2. The g has a y-intercept of 1 and a y-intercept of 2. So now we're down to these two. And now we just compare the slope. The slope has to be negative 1. Well, as we talked about before, g has a positive slope because it goes into the direction up and to the right and into this positive quadrant. So it has a positive slope. You could do the math and figure that out, do the rise over the run, and you could calculate that. But you don't have to. You just have to know positive versus negative slope. This graph has a negative slope of 1. If you go from this point right here on the y-axis, if you go down 1, that's the negative, and to the right 1, because it's negative, you can do negative 1 over 1, or you can do it as 1 over negative 1. If you do it this way, negative 1 over 1, you go down 1, that's the negative, and then to the right 1, that's the positive. If you do it the other direction, slope being 1 over negative 1, both of these are negative 1 slope. There's just two ways of doing it. 1 over negative 1 means you would go to the right 1, which is positive, and then down for the other. This line right here, this first line has a negative 1 slope, and this second line, if we started on 2 and we went to the right 2 and then down 2, we would be back on the line. 2 over 2 is 1, so it's a negative 1 slope. So any way you slice it, this line or boundary is the x plus y greater than 1, and this other one is the x plus y less than 2. So there's all these different ways that you can go about answering this question.